Hello students, good evening. So today we'll start the next topic of this chapter, that is electrostatic chapter for NEET, JEE and yeah, IIT. Okay. So this is a handwritten notes and some important points by me. So therefore let us start the chapter. So here you can see charges are always created in pairs. So the charges are created in pairs. So we have two types of charges. One is positive charge and other one is negative charge. So in every atom there will be equal number of positive charge and negative charge. Hence it will be neutral, and there is a positively charged nucleus inside the atom. Okay, and it has two components. One is the neutrons and the protons. Protons is positively charged and neutrons is neutral. Hence the charge of the nucleus is given by the protons only. Hence it is a positively charged centrally located body or a structure of the atom. Therefore the net charge on the atom will be 0. So as there are so how many protons are there? There will be that many number of uh, that many number of electrons revolving around the nucleus, right? Therefore, let us take the atom here, and there is a centrally located nucleus, and this nucleus is positively charged, okay, because of the protons present in the nucleus. And here surrounding the nucleus there will be electrons which are revolving around the nucleus. They are negatively charged, and the number of electrons is equal to number of protons, right? And the next point we will see, whenever there is a friction, there is exchange of electrons from the body, which the atom which loses the electron will be positively charged, and the body which gains the electron becomes negatively charged. Therefore, charge is carried by material, or charge cannot exist without the material. Okay, when there is friction, then only there will be transfer of charge from one body to another body. Okay, now let us see the methods of electrification, that is charging of a conductor. So here you can see there is a negatively charged body and positively charged body. So due to mutual repulsion always in a conductor, charges reside only on the outer surface of the conductor. Okay, charges are distributed on the conductor outer surface in such a way that the potential energy is minimum. Any system will be held in equilibrium only when the energy of the system is negative, and any system which is stable have negative potential energy, and total energy will also be negative. So now let us see how the charges will be conducted. So charging by conduction. Now if you see, you can see here in the diagram. So here when a charged metal body is connected to another uncharged metal body, charges flow to a neutral body. So first of all, when there is a charged body, so suppose this is a negatively charged body, and this one is another uncharged body, the electrons will flow into this. So that the two metals are in contact with each other in the conduction. So these charges are flowing here when they are contact with each other. Okay, so this is the method of electrification by charging. So in charging, the material will be in contact and depends on the dielectric strength K of the material. So let us see the next one, charge distribution on an isolated conductor. when some charges is applied to an isolated conductor, it is distributed on the outer surface in such a way that the surface charge density, that is charge per area, that is a coulomb per meter square, is inversely proportional to the local radius of the curvature of the body surface. Okay, so that is sigma is inversely proportional to the radius. Okay, when charge is applied to the maximum, the density of the charge on the body surface will be in the on the surface of the conductor. Okay, now let us see the friction due to electrification due to friction. When two bodies are rubbed against each other, okay, due to friction, electrons from one body get transferred to the another uncharged body. You using friction, bodies can be charged only uh, if at least one body is an insulator, because if two metals bodies are rubbed against each other, even if electron transfer take place, that due to metals are in contact due to conduction, again the body will become neutralized. Okay, now charging by induction. So charging by induction means there are metals and the bodies are not in contact with each other. There is separation of, due to external effect, separation of charges in a body is called charge induction. Okay. Now let us see the charge induction in atoms and non-metals, in metals and non-metals. So here, due to presence of an external charge, a neutral atom is transferred into a dipole. This is called polarization and of an atom. Polarization of an atom. So what is polarization of atom means? The atom gains positive or negative charge. So when it loses, it gains positive charge. When it gains, it has the negative charge. This is known as the polarization of the atoms. Polarization is nothing but the poles, that is positive pole and the negative pole. Right. Now let us see what is meant by Coulomb's law. Coulomb's law is an electrostatic law. So it is the force of attraction or repulsion between two charges which are separated by a distance r, and there is a dielectric constant k. If there is a for free space it is epsilon naught, and if for the medium it will be epsilon m. Okay. Now q, that is F, is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the two charges. So here you can see two charges are there, q1 and q2, separated by a distance r. That's why force of electrostatic force is proportional to q1 and q2 and inversely proportional to r square. So we can write the force as F equal to k q1 q2 by r square. Now k is a electrostatic constant which is the depends on the medium. Okay, and k value is given by experimentally as it is given by 9 into 10 raised to 9 Newton meter square per coulomb square. Okay, force in free space is given by 1 by 4 pi epsilon naught q1 q2 by r square. Right. So this is the Coulomb's law statement. So in vector form also we can write the Coulomb's law, that is, so here you see in vector form always we will consider the force from which direction, the force in which direction. Okay, so let us take F1, here we will take F1 and we will consider this as the F2. Okay, so F1 equal to k q1 q2 by r1 square, and F2 to equal to k q1 q2 by r square, right? Now these forces are equal and opposite. So this is the force from the q charge due to q1. This is the force of the charge q2 due to q1. Now they are equal and opposite. Hence we can write f dash is equal to minus of f. They are equal and opposite. Force dependency on the medium. When the charges are submerged in a medium, the force exerted by one charge on another does not change, but due to polarization of the medium, the dipole net force on both the charges decreases. Thanks for watching.